So the first thing is that I think there is some typo with the professor's answer because in the question, firm two will not have the choice of investing, so it could be firm one here, and mm, the Nash could be solved like this. So the game goes like the firm one would have a choice of investing say I and not investing N in the first period, and then in the second period that they would play a simultaneous to move duopoly game. So we have something like this. It's better to not write it like that though. So we have a simultaneous move to duopoly game, choosing Q1 and Q2 in the second period. And so the goal here is we want firm one to not invest. So the firm two need to behave suboptimally, not optimally, when firm one invests in order to push firm one to not invest. So when firm two actually successfully push firm one to not investing, then firm two should behave optimally here. And firm two, as I said, should not behave optimally here in order to push firm one to not investing. So the correct Nash equilibrium, I think, goes like this. So in the first period, the firm one will choose to not invest, and in the second period, we need to specify after each history how do these two firms behave. So after history I, firm one would say still six would be okay. And the important thing here is after investing, firm two should not behave optimally, say Q equal to 20, such that firm one will not invest because when Q is 20, firm one's profit will be smaller or equal to zero. So firm one will probably not want to invest in that case. And we need to specify what happens after history N as well. So then, as I said, they need to behave optimally. So the Nash equilibrium that we calculated before should be optimal for both of them. So in order to prove that this thing is a Nash equilibrium, we need to prove that on the equilibrium path, in both of them are behaving optimally. So we don't actually care about the behavior after I because it's never reached. So we only need to prove that this subgame has a Nash equilibrium, and this is the optimal choice for me to prove this is optimal for firm one. And we know that from the part A that 6 will be a Nash equilibrium already. So the only thing left is to prove optimality for firm one. So firm one in the first period is deciding whether to invest or not invest. As, as, as this profile suggests, if I invest, I will get pi smaller or equal to zero because firm two is choosing quantity 20. And if I do not invest, then we are in the 6 in the Nash equilibrium, so we have a positive profit as we computed. So N is actually optimal for firm one, and I think that will be all you need to say in order to prove that this is Nash.